So today we are discussing about the covalent bonding. In the covalent bonding, there is a sharing of electron. There is a mutual sharing of electrons between atoms. And this mutual sharing of electrons produce a covalent bonding. The basic motive behind the covalent bonding is to get the last shell electronic configuration of noble gases and to get stability. I just like to recap about the noble gas last shell electronic configuration and the stability. For example, if it is helium, there is having 2 electrons. There is only one shell with helium. It is the first shell, and it is the only shell with the helium, and it is having 2 electrons. So the first shell, which is the only shell, and it is having 2 electrons in it, and that is called a duplet. And hydrogen would like to follow this electronic configuration of helium. Hydrogen belongs to group 1, and it is having 1 electron. And the second hydrogen is also having 1 electron. So 1 electron is shared. And this is the common region between the 2 atoms. And the 2 electrons will come in the common region. And there is a mutual sharing of electron. Each atom will contribute 1 electron for the sharing, and that is the mutual sharing of electron between the 2 hydrogens. And that means that this pair of electron will be counted for both of the hydrogens. I mean, this hydrogen is having 2 electrons, this hydrogen is having 2 electrons, so shared electrons are counted for both of the hydrogens. And in this way, hydrogen has got 2 electrons, and this hydrogen also has got 2 electrons. In this way, each hydrogen has completed its duplet, having the last shell electronic configuration like the helium, like the noble gas helium, and has got stability. And when one hydrogen and second hydrogen are sharing the electrons, these electrons are like this, that electronic cloud is there between the 2 nuclei, and this nucleus is having proton, this nucleus is having proton. So this proton will attract this electronic cloud, and this proton will attract this electronic cloud, and that will be the force of attraction that will bind the 2 hydrogen atoms together. And such a binding, because of the sharing of electron, because of the mutual sharing of electron, in which each hydrogen is sharing equal number of electrons. This hydrogen is sharing 1 electron, and this hydrogen is sharing 1 electron. So that is the mutual sharing of electron, and the sharing of electrons of equal number of electrons by each hydrogen will give us the covalent bonding. And because I've already told you that hydrogen proton and hydrogen protons are attracting the electronic cloud, and that will become the force of attraction and bind the 2 hydrogen atoms together. When atoms join together, it will become H2, and this is the molecule. So when it is independently, it is 1 hydrogen nucleus, it is atom. If there is 1 hydrogen nucleus, it is atom. But when something is obtained in which this is acting as a 1 body now, I mean H2 is acting as a 1 body now, and it is having 2 nuclei, hydrogen, this hydrogen nucleus and this hydrogen nucleus. So it is a molecule. Molecule is having more than 1 nuclei. So if there is more than 1 nuclei, it is molecule. But if it is having only 1 nucleus, it is called atom. So we have got hydrogen molecule because it is H2. And we can also show it like this way, that this hydrogen is having 1 electron and this hydrogen is having 1 electron. So there is a mutual sharing of electron. By the mutual sharing of electron, 1 electrons will come between the 2 between the two hydrogen atoms and between the two hydrogen nuclei, and this is one pair of electron, and this hydrogen nucleus is attracting it, and this hydrogen nucleus is attracting it, so that force of attraction will bind them together. This is the one pair of electron, and one pair of electron is shown by one bold line, and single one bold line between two hydrogen atoms is called single covalent bonding. And this is how I described it about the hydrogen molecule with the help of the covalent bonding. Covalent bonding is formed between the non-metals. If one atom is a non-metal and second atom is a non-metal, the bonding between non-metal is a covalent bonding. Generally speaking, covalent bonding is formed between the atoms of different elements from group 4, group 5, group 6, group 7, and hydrogen. So when various atoms of this group will join together, we get covalent bonding. And covalent bonding is between the non-metal and the atoms of the different elements I just described, hydrogen, then the group 4, group 5, group 6, and group 7, they are the non-metals. So the bonding between non-metal and non-metal is the covalent bonding. So to illustrate my point more to all of you, I am giving you more examples so that you must be very clear about the covalent bonding. For example, my second example is chlorine. Chlorine belongs to group 7. And group 7 means group number, tells us the number of electrons in the last shell. And to show the covalent bonding, I am showing the nucleus as well as the last shell. And the last shell I'm showing because it is only the last shell electrons which are taking part in the bond formation. So the chlorine belongs to group 7, and group number tells us the number of electrons in the last shell. So it is group 7, so it is having 7 electrons in the last shell, 1, 2, 3, 4, 5, 6, 7. And the second chlorine is also having 7 electrons, 1, 2, 3, 4, 5, 6, 7. And this is the chlorine nucleus, and these are the last shell electrons of chlorine. Chlorine would like to get the last shell electronic configuration of noble gases to get stability. And I am just showing you about the last shell electronic configuration of neon. Neon is having 8 electrons in its last shell, 1, 2, 3, 4, 5, 6, 7, 8, and it is having octet. Similarly, argon is the next noble gas element. It is also having 8 electrons in its last shell, 1, 2, 3, 4, 5, 6, 7, 8, and it is having an octet. Similarly, chlorine would like to get the same octet. I mean, in the last shell, chlorine would like to get 8 electrons to get the last shell electronic configuration of noble gases to get stability. So it is having 7 electrons. It requires 1 more electron to get octet. So one electron is needed to be shared. So only 1 electron is needed to be shared. So it is a single covalent bonding. And this electron and this electron, these 2 electrons will be shared, so that is a mutual sharing. So each chlorine will share 1 electron, so equal number of electrons are shared by each atom. That is what the covalent bonding is. So I mean, one electron are shared between 2 chlorine atoms, and this is the chlorine nucleus, this is the chlorine nucleus. So this chlorine nucleus will attract, having nucleus having proton, so this proton in the nucleus of this chlorine will attract the electrons. Electrons are negatively charged, and nucleus having proton which are positively charged, so proton positive, electrons negative. Similarly, this chlorine nucleus is having proton having positive charge and electrons having negative charge, so this proton will attract it and this proton will attract it. That force of attraction will bind them together, and there is one pair of electron, so it is a single covalent bonding between chlorine, but in this way it has got octet in the last shell. I can count the electrons: 1, 2, 3, 4, 5, 6. These 6 electrons belong to this chlorine, and this pair of electron will be counted for both of chlorine this and chlorine this, because the shared pair of electrons are counted in both of the atoms which are involved in the covalent bonding. And this chlorine is having 1, 2, 3, 4, 5, 6, these 6 electrons of this chlorine, and these 2 electrons are counted for both of them, and so 1, 2, 3, 4, 5, 6, 7, 8. So this chlorine has got 8, 1, 2, 3, 4, 5, 6, 7, 8. This chlorine has got 8 electron, this chlorine has got 8 electron, and in this way the last shell electronic configuration, like the noble gases, is attained. Both of the chlorine have got octet to get stability. Chlorine is a non-metal. The bonding between the non-metal is a covalent bonding, as well as it is a sharing of electrons and the mutual sharing of electron. Each atom is contributing equal number of electrons for the bond formation, and because of the mutual sharing of electron, it is a covalent bonding. And the electrons, like a cloud, are lying between the 2 nuclei. So both nuclei are attracting the electronic cloud, so that will the basic force which will join them together. So one chlorine when joined, so 2 or more than 2 atoms when joined together, 2 or more than 2 atoms when linked together. So that linking and that connectivity between the atoms is called a molecule. So Cl2 is a molecule. It is a diatomic because 2 atoms are joining together. And I can show it like this way, that this chlorine is having 7 electrons, this chlorine is having 7 electrons. 1 atom electrons are shown by cross, and the second atom electrons are shown by dot. 1 electrons are shared, so there is a pair of electron which is shared between 2 chlorine, because it is only 1 pair of electron, so it is a single covalent bonding, and this is chlorine. So we talk more on the examples of the covalent bonding, and you see the motive behind the covalent bonding is same, and the motive is to get the last shell electronic configuration like the noble gases to get stability. So it is a stability that is a basic motive and basic reason behind the atoms to join together to make a variety of molecules. For example, if I give you one more example, like oxygen, one of the very, very important element with us, our survival is depending upon oxygen. Oxygen, it belongs to group 6. When oxygen belongs to group 6, it means it is having 6 electrons in its last shell. So, I mean, 1, 2, 3, 4, 5, 6. This oxygen is having 6 electrons. There is an oxygen nucleus, and there is an oxygen nucleus with the second oxygen atom, and oxygen belongs to group 6, so it is having 6 electrons in its last shell, and this oxygen is having 6 electrons in its last shell. It requires 2 more electrons to complete its octet, and because it requires 2 more electrons, so 2 electrons are shared, so each oxygen will share 2 electrons to get octet. So remember that they need to complete the octet to get 8 electrons, but they have 6 electrons, they need 2 more. So they want 8 electrons, they have 6, so they have to contribute 2 electrons. Each atom of oxygen would need to contribute 2 electrons. So this oxygen 2 electrons, this oxygen 2 electrons, so that is a mutual sharing of electrons. So this electron will be shared with this electron, and this electron will be shared with this electron, and these electrons are shared, so there is a mutual sharing of electron. Each oxygen is sharing 2 electrons, and because there are 2 pair of electrons shared between the oxygen to get octet, and to get the stable electronic configuration like the noble gases. So this is oxygen, oxygen, oxygen molecule. O2, it is also diatomic because two oxygen atoms join together. And if I count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8. So these pair of electrons are shared between both of the oxygen because they are the shared pair of electrons. And for this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So, I mean, this oxygen has got 8 electrons, this oxygen is having 8 too, this oxygen is having 8 electrons, this oxygen is having 8 electrons. So both of the oxygens have got the last shell electronic configuration of noble gases, and they have got octet. So this is the oxygen nucleus, this is the oxygen nucleus, and the electronic cloud is between the two nuclei, and this proton of the nucleus of oxygen will attract the electronic cloud, and this proton of the oxygen nucleus will attract the electronic cloud which is lying between the two nuclei, and in this way oxygen atom and the oxygen atoms are joined together. That is the binding between them, that is the force of attraction. The O2, I can show it like this way. This oxygen is electron will share with this oxygen, and this oxygen will share its electron with this oxygen. So the two electrons are shared. So that is a double covalent bonding because two electrons are shared between two oxygen. It is a double covalent bonding shown by two bold lines between oxygen and oxygen. So it is called a double covalent bonding. And you know the reason, I mean, you are very expert now about the covalent bonding because the case is very simple to understand, and there is a single motive behind to make the covalent bonding. For nitrogen, nitrogen belongs to group 5. I mean, you are allowed to look at the periodic table even in your examination hall. So you can look at the periodic table and you can find that nitrogen belongs to group 5. So nitrogen belongs to group 5. So 1, 2, 3, 4, 5. So this nitrogen is having 5 electrons. This nitrogen obviously have this nitrogen also has 5 electrons. 1, 2, 3, 4, 5. So nitrogen has 5 electrons in its last shell. It requires octet. It needs 8 electrons. It needs 3 more because it has 5 and it needs 8, so it needs 3 more electrons. So each nitrogen is required to contribute 3 electrons for the bond formation to get octet. So this nitrogen will share its 3 electrons. So 1, 2, 3. So 3 electron cross electrons from this nitrogen, 3 electrons like dot, 1, 2, 3. So the 3 electrons are shared between nitrogen and nitrogen, and because of this they have got octet. We can count it 1, 2, 3, 4, 5, 6, 7, 8. So these electrons lying in the common region between two nitrogens. So these electrons are counted in both of the nitrogen, this and this. So 1, 2, 3, 4, 5, 6, 7, 8. And for this nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So this nitrogen has got octet. This nitrogen has got octet, have got the complete last shell electronic configuration like the noble gases, and both of the nitrogens have got stability. And this is nitrogen nuclei, this is nitrogen nucleus. So nitrogen nucleus, these are the electronic cloud between the nitrogen nucleus. So this proton will attract this electronic cloud, this proton will attract this electronic cloud, and that is the reason that they will bind together to give a nitrogen molecule N2. And in this way the nitrogen, because the 3 electrons are shared between nitrogen, so it is a triple covalent bonding shown by the 3 bold lines between nitrogen, and we call it triple covalent bonding. So this nitrogen, and the 3 electrons are shared between nitrogen, and in this way we have completed an octet for each nitrogen. And this is about the covalent bonding, and in this way it has attained the last shell electronic configuration like the noble gases.